Let's do problem number 33 on page 171. I will read the problem. 5 forces act on an object. The first force is 60 newtons at 90 degrees, and then 40 newtons at 0 degrees. The third force, 80 newtons at 270 degrees. The fourth force, 40 newtons at 180 degrees, and the fifth force, 50 newtons at 60 degrees. What are the magnitude and direction of a sixth force that would produce equilibrium? Okay, let's write this out. And I'm gonna write this out a little bit. I'm gonna go F1, F2, F3. And these are given in polar coordinates. So F1 is 60 newtons at 90 degrees. F2 is 40 newtons at 0 degrees. F3 is 80 newtons at 270. The fourth force is 40 newtons at 180. Was it 40? Oh, that's handy. And the fifth force is 50 newtons at 60 degrees. Well, that's merciful. That's the only one that's not lined up. This isn't that hard. It looks like it's hard. And then it says we want to find a sixth force given that it's in equilibrium. Equilibrium means that the acceleration is equal to 0. So let's solve this. Now, I'm going to solve this using the procedure. There's 2 ways to do this. You can add all the forces, F1, 2, 3, 4, 5. You can add them together. And then find the resultant force. And then F6 is the equilibrant force of that. So you just take that same force and then add 180 degrees to its angle, and that will give you the force that will hold it in equilibrium. I'm going to use the procedure for this instead. So let's just have an object. I'll just draw the object as a dot. And we're going to draw these forces acting on it. F1 is 60 at 90. So here's F1. And F2 is 40 at, there's F2. F3 is 80 newtons. I'm sorry, 80 newtons at 270. Well, what is 270? That's straight down. There's F3. And then F4 is 40 newtons at 180. And then F5, this is the only force that's going to need to be broken up into its components. 50 newtons and 60 degrees. So 60 degrees, 50 newtons. So here's F5. Now, these two cancel each other. This is bigger than that. So I'm going to guess that F6 needs to be like this. But I don't really know. I don't really know what F6 is, what direction it should be. That's my unknown. So I'm going to very carefully now, well, I'm going to say this is the X direction and this is the Y direction. Now we're in step 3 of the procedure. This is step 1, drawing all the forces acting on our object, including our unknown force. And then the next step is to break this up into its components. So here's F5 in the X and in the Y. So now I'm going to sum the forces in the X direction equals MA in the X direction. And I know that this is 0. So let's look in the X direction. How many forces are in the X direction? Well, F2 is in the X direction, 40 newtons. And then F4 is in the X direction, but it's minus 40 newtons. So I think you can see these two just cancel each other out. You can even just like scribble them out. They don't do anything in this problem. And then F5 in the x. Well, what is that? Well, that's 50 newtons. And in the x direction, it's cosine, right? Cosine of 60 degrees. Let's go ahead and put the 60 in there. And then we have F6. Now, I don't know if it goes over here or over here. I really don't have any idea where. So I'm just going to put plus F6 in the x direction goes, right, like that. Now, when I do this, if this turns out to be a negative value, that just means, oh, it's to the left. If it's a positive value, it'll be to the right. And actually, I can go ahead and do this. F6 in the x is really equal to, well, these two are going to go away. And, well, I do know it's going to be in the negative x direction, right? Because this is going to be over here, minus 50 newtons times the cosine of 60 degrees. What is the cosine of 60 degrees? You should know that. Boom. You have that memorized, right? Oh, she already went. Very good. What? It's 1/2. So what's half of 50? 25. So it's negative 25 newtons. That's equal to F6 in the x direction. So we know the x component now. All I got to do is do all this again in the y direction. And so I look in the y direction. I got F1. And then plus F5. And well, what is F5? 50 newtons times the, what would that be? Sine of 60 degrees. Minus F3. Well, what is F3? 80 newtons. And minus, because we know it's down. And then plus F6 in the y direction, and that's all going to be equal to 0. So I just looked at my free body diagram. I used the free body diagram to construct this equation. I look at it, so okay, F1 minus F3 plus F5 plus F6, maybe it's plus, maybe it's minus. We'll leave it as plus for now, and if I get a negative answer, I'll know it's down. So F6 in the y. Oh, I should have just plugged in a value here because I did that for all the other ones. Well, what is F1? I'm going to subtract that to the other side. F1 is 60 newtons. So that'd be minus 60 newtons, right? Because I bring this over here. And then minus 50 newtons times the sine of 60 degrees plus 80 newtons. So to do this, I need my calculator. If I can find it. Oh, here we go. So I'm just going to start off with 80 newtons over here. So 80 newtons minus 50 times the sine of 60. And then minus 60. And I get negative 23.30 newtons. Does that make sense? Let's see. This is more down. You got up, up, some down, but these two ups are bigger than this down. So F6, evidently F6 has to be down like this. Not like this. So I guessed wrong. That's okay. I guess wrong all the time. So it's going to be in the third quadrant because it's got a negative x component and a negative y component. Well, let's figure out what F6 is. It's the square root of its x component plus its y component. And if you see me making a mistake, please let me know so this doesn't carry on to posterity. Just typing this in the calculator, and I get, when I do this, I get 34.2. That looks reasonable. Well, that's the magnitude. Now, what's the direction? The direction is the inverse tangent of its y value over its x value. And then I have to add 180 degrees to my answer, and these negatives cancel. So, second function for tangent, 23.3 divided by, should be just under 45 degrees, divided by 25, and I get 42.98. How did I know it was just under 45? When the y value is the same as the x value, you know it's going to be 45 degrees. But when the y value is a little smaller than the x value, you know it's still going to be a little less than 45 degrees. So, and I think about that. Why do I think about that? To check my work as I go. So if I make a calculator mistake, I can catch it, not write it down. So I'm always thinking while I'm doing this. Now I have to add 180 degrees to that. And I get 223 degrees. So I've got my finished answer now. It's got a magnitude of 34.2 newtons and an angle of 223 degrees. So let's zoom all the way out here. We are zoomed out. Lift that so you can see the whole problem. And let me check my work. This is number 33. Oh, it's 34 newtons, 223 degrees. Very good. Put a big star next to that, next to that. Now, again, you could have done this a little bit differently, where you add these together, like when we added vectors. We just add all these vectors together. You get a resultant vector. The resultant vector will be 34.2 newtons at, what was that, 42 degrees, and then you add 180 to it to get the equilibrium force, and you'll get the same answer. Either way works for me, and works for this problem. Any questions? Okay, that is all.
Yes.